So the first problem today, fan poll. In this problem, we have been told that we would be given three integers A, B, and C, which are the number of votes given to Dhoni, Rohit, and Kohli, and we have to tell if Dhoni won the poll or not. So Dhoni would have won the poll if he has got the highest number of votes, and we just have to tell if Dhoni won or not. So I think that everyone would have solved this problem. We just have to compare if A is greater than B and A is greater than C. If both the conditions are true, it means that A is the greatest number. So print yes, otherwise print no. Fine. I don't think anyone would have any doubt in this. Okay, so let's move to the second one. Let's move on to the next problem. Survival time. In this problem, we have been told that there is a family of five people. There is a family of five people. Everyone needs maybe yeah, everyone needs X buns every day. So since there are five people, they would require 5x buns every day for living, for surviving. And once once the buns are finished and they don't eat anything, they can survive for d number of days. And we just have to tell for how many days did they survive. So in this problem as well, it is pretty simple that you are being given n buns. You see that everyone, like every day, you require 5x buns for survival of the family. And one more thing is being given that in case if the buns are not enough for every member of the family, in that case, no one needs anything. So we just need to find out n by 5x to find out for how many days the family members can eat buns, and plus b for the number of days the family members would be able to live without buns. This would tell us about for how many days the family would be able to survive. This is also something very simple, so I think that most of you would have already solved. Is there anybody having any doubt in the first two problems? And the code here is just like this, that since there are multiple test cases, take t as input, and then the first line gives us n, x, and d as input. After that, okay, no, okay, so it's clear. That's good. So since there are five family members, the I'm just incrementing five, like multiplying x by five because I would require 5x buns every day. Then n by x for finding out how many days people can live without with the buns they have, and then plus d for the number of days they can live without buns. This was also pretty simple. Let's move on to the next problem. In the third problem, we have been given that Chef is forming a team for Dream 11. So he has to form a team of 11 members, 11 players. He has decided these 11 players, but now he has to decide a captain and a vice captain for the team. From these 11 people, he uh, decided that he would be like he shortlisted n people, n players, and he would be deciding the captain and vice captain from these n people only. And a player cannot be the vice captain and captain at the same time. So you have to choose two people from these n people and tell how many ways are there to do it. So I think that this is also something direct, that for the first case, for the captain role, you have n choices. You can have n people whom you decide to be the captain, and then you will have n minus 1 choices. After this, you will have n minus 1 choices to decide the vice captain, and that would be your answer. Anybody who could not solve this or have any doubt in this, I can repeat it once, that we have n people from whom you want to choose the captain and the vice captain. A single K cannot be the captain and vice captain at the same time. So basically, you first have to choose the captain. You have n choices for that. Then you have to choose the vice captain. Since you cannot have that guy you choose earlier as the vice captain as well, so you will have n minus one choices this time, and that's it. Their product is the total number of ways we have to choose the captain and vice captain. So we would just for every test case we would just take up n as input and print n into n minus one. Let's move on to the fourth problem. Now this was the first problem of division one. Earlier was very easy problems. Now even though it's not hard either. So this problem says that we would be given an array of n integers, and we have to find this number of sub arrays in the array A of length k whose bitwise OR is odd. So we have been given an array. There is an array A which we have been given, and we have to find out how many sub arrays of length k are there whose bitwise OR whose bitwise OR is odd. So first thing you can see is that for a number, like for a subarray or for a sequence of numbers having their bitwise OR as odd, it doesn't really matter what the numbers are. What matters is whether the numbers are odd or even. Because if there is any number which is odd, the bitwise OR of those numbers would become odd, right? Because what we see is that in the OR operator, we have 1 or 0 is 1, 0 or 0 is 0, 0 or 1 is 1, and 1 or 1 is also 1. So only the case where all the numbers are even would be the case where we don't have the bitwise OR as um, odd. Otherwise, in all the cases where we have at least one odd number in the subarray, they would be uh, having the bitwise OR as odd. So what we can do is just use sliding window. How would we get the intuition of sliding window? Because we have to consider only the subarrays with length k. So it can give you the hint of using sliding window. One way of solving the problem is that for every element you can just say that take its modulo with 2, so that it would either be 0 or 1. All the odd elements will become 1 and all the even elements will become 0. Now for every subarray of length k, you just need to check if um, there is any element greater than or equal to 1 or not. That's what you have to check in that case. And in the sliding window, we know that initially we consider the sliding window of length k. After that, we insert the next element and uh, just discard the first element, so that this would become my sliding window of length k. After that, I would add this element and remove this one, so that this would be my window of length k, and so on. If you don't know what sliding window, then you can study about it. So in this is pretty standard thing. That's what I did here. That for the array I have, I just took its bitwise and with 1, so that all the odd numbers will become 1 and all the even numbers will become 0. After that, I declare two variables answer and count, and I just applied that sliding window every time adding that element. And uh, when I'm at index k or above, I would just remove a of I minus k from the subarray or from the window. And after I is greater than equal to k for all those I would increment the count of answer if the count c and t is greater than 0. This is nothing but sliding window thing. So is this clear or not? And is there anybody who has any doubt in this problem? Okay, great. So let's move on to the next problem then. This is the problem, guess the winner. In this problem, we have been given an integer n, and we have been told that Alice and Bob will play a game in which uh, on the turn of any of those players, the player must choose an odd prime factor of that integer n and subtract it from n. So n was the number. Let's say it is Ali's turn. In that case, Alice would have to choose a prime factor, an odd prime factor p of n, and change n to n minus p. Basically, subtract p from n. And the player who cannot make the move, which would happen either if n is equal to 0 or n has no prime factors, in that case, that player will lose. So we have to tell who will win the game if Alice and Bob both play the game optimally. Now, this was somewhat an observational problem in which you had to make up some observations. Like the first observation here is that in case, let's say, if n doesn't have any prime does not. Okay, first let's start with this. What are the prime numbers? What are prime numbers? Anything like the numbers like 2, 3, 5, 7, and so on. 2 is the only even prime number. 2 is the only even prime number. Other than that, all the numbers are odd prime numbers, right? Except 2, you like all the prime numbers except 2 are odd prime numbers. So if there is a number who has any prime factor other than 2 as well, in that case, we can see that the number is having some odd prime number, right? Sorry for that. I don't know why the mic could not mute. Okay, let's come back. So what I was saying is that among all the prime numbers, 2 is the only even prime number. Other than that, all the other prime numbers are odd. So if I divide n by 2 and the remainder is 0, like while this condition is true, I just keep dividing n by 2. In that case, I would come up to a situation where this n is not having any even prime number as its factor. So if n is equal to 1, it means that um, it doesn't have any odd prime factor. In that case, I can say that Elise would lose. It was Elise turn in the beginning, and she doesn't have any uh, odd prime factor of n. So Elise will lose. Elise lose. In case if n was not equal to 1, if it was something greater than 1, then there can be two cases. Initial n which I had before dividing was even or it was odd. What I would be doing in every move is simple. I would be choosing some odd prime factor, which means that I would be choosing some odd number and subtract it from n. So it means that initially whatever n was like odd or even, if it was odd, then it will become even, and if it was even, then it will become odd, right? So let's say if n was and at some point of time n will become equal to 0, that is gonna be the even turn. In that case, whoever's turn it is will lose. So you could just very easily see that in case if it is even, let's say if it is something like 6, then in the first turn 3 would be minus, and then you will have 3, and then 3 would again be subtracted, it would become 1. Initially it was Ali's turn, then it was Bob's turn, and then it would be the turn of the guy who played the first move, that was Ali's. So if that number was initially even, in that case Alice will lose, so Bob will be the winner. Otherwise Alice would win in case if that number didn't have any prime factor of 2, if it was already odd. Right, please confirm it once whether what I said here is clear or not. And does anybody have any doubt in this? Okay, let me explain it once again. In this problem, we had been given an integer n. What we had to do in every move, what we had to do in this was choose some odd prime factor p, and subtract it from n. So the first thing which should come to your mind is, what if there is no odd prime factor? Then Bob will win, right? How will you check if there is any prime factor or not, odd prime factor or not? One thing is that you can just try to run up a loop, but it won't work in this case, since the n, like, value of n is quite large and number of test cases are too many. So it would not work. But for checking if there is any prime factor, you don't really care about which prime factor, odd prime factor is available or not. What you can do is just say that, hey, n would be equal to 2 raised the power something, let's say x, into some odd prime factor key power something, let's say p1 raised the power s1, then p2 raised the power s2, and so on. है ना? We can say that every number is like this. I would just cut off this part. I would divide n by 2 as long n is divisible by 2. I would divide it. After that, I would be left up with n being a product of some prime factors, some odd prime factors, if there are any. So in that case, I can just check that, hey, if n is equal to 1, it means that n is not having any odd prime factors. So I will say that Bob is winning. In case if n is greater than 1, if n is greater than 1, there, what will happen is, for the original value of n, which was for, like, whatever be the original value of n was, it would have got some p being subtracted from it, right? Whatever n was, it got some odd value subtracted from it, and it will get odd value subtracted from this again and again, until this n becomes 0, right? Is this part clear? Is this much clear? Okay. After this, you see that if that number you initially had as was 0, that initial number you had was 0, and you're subtracting odd number from it again and again, then after even number of times it will become 0. In case if that initial number n was odd, in that case it would become 0 after odd number of times, right? Again, very simple thing. You can take some examples, like what if n was equal to 9, what if n was equal to 12, and so on. In that cases, you will see that in case if the game is ending after odd number of turns, it means that Alice would have played the last turn, and after that Bob failed to play the turn which Bob had to play. So Alice would be winning. But if that number was even, in that case Bob would be winning, right? So you can just keep track whether you had initial number was even or odd. Maybe whatever n I took as input, I can just say p is even, equal to n divisible by 2, equal to 0. I can just find if n is even or not. After that, I can divide n. As long as it is divisible by 2, I can just keep dividing it. And then I can have these three cases, that if n is equal to 1, it means that it is not having any odd prime factor. So just say Bob 1. Otherwise, if the number was even, like, if is even is false, if it is not even, if it was odd initially, in that case Alice will win, and otherwise Bob will win. And obviously there can be some other ways of writing this as well, but, like, instead of this you could have said it even easily, that if n equal to 1 or is even, in both those cases Bob will win, otherwise Alice. Obviously if else is something you can write on your own also. So that's what I did here. I just kept track of how many times I divided the number by 2. If the number became 1 after divisible and dividing it by 2 again and again, in that case, Bob will win. Otherwise, Elise will win if count is 0, which means that the number was initially odd. And in case if the number was initially even, in that case, Bob will win. So is this clear? Should we move on to the next problem? Please say yes or no in the chat. Okay, great. So this is the problem, save people. In the problem, we have been told that there is something like a matrix of size n into m, and there is a cell xy. There is a cell xy from where infection would start. Like people would start to get infected, and they have actually given some visual representation as well that how this virus spreads up or this infection spreads up. You can see that in the first move, the virus will start from one cell. You will have some counter for that. You will start vaccination from somewhere. Then in the next move, virus will spread, then you, then virus, then vaccination, and so on. You know, you can look at it more times if it's not clear to you even now. So what we have to do is just choose some cell for vaccination. You don't have to tell the cell you choose, but you have to tell about the cell of which will get vaccinated, the count of the cells which will get vaccinated. You have to tell about the count of this green number of cells. And I think that you would have already read the problem as well, so should not be a problem in understanding it now. They have explained it pretty well. So, like virus or the vaccination will spread. For any cell, it would spread on the right, left, top, down, horizontally and vertically connected cells, and that is same for vaccination as well. And here you just had to come up with an idea that if vaccination is starting, maybe let's say, sorry, infection is starting, let's say at this point, and I choose this point for vaccination, then these cells, like the cells which are closer to this infection source, the source for infection, will also get infected. And the cells which are closer to the cell from where vaccination is starting will get vaccinated. है ना? This was the observation. So you would want to have maximum number of cells which are closer to the yellow color, right? Or that green color actually. According to the problem, they have used the green color. So the intuition here, the idea here actually is just that I can choose either this one, this one, this one, this one. One of these four cells will be giving me the best output. One of these four directions would be giving me the best output. The reason is because let's say if instead of this, I was choosing this guy, then there would be some cells which would get infected, which could have been protected if I had vaccinated this cell first. Right. You can just observe this part, and with this, we can say, before that, please confirm it once whether this part is clear or not before going ahead. Whether this part is clear or not. Okay, great. So now what we can do is individually check for every option we have. We have only four options. Individually check for them. If I chose this place, then all these cells are close. All these cells are closer to the infection. These are close to infection, and these guys are closer to vaccination. So I would be saving these people, right? So if I choose the right cell, in that case, I will have n into x. This many, I would have this many people getting infected. I can just say n into m minus n into x being the number of people I saved. And similarly, if I had chosen this guy, then this would be the line. In that case, some like the number of columns into this guy, like these. Basically, in that case, I want to find out the area of these people which are getting infected. This part is nothing but m, and this part is nothing but sorry, this part is x. Initially, it was n into y for the last case. You just find out this area and subtract it from the whole to find out these people. Yeah, it is like simple mathematics, school level mathematics. For finding out the area of this size, you just have four cases. The infection was here, so you uh, chose this guy and saved these people. Or you might have chosen the cell at the downside at the uh, bottom place. So in that case, these people would have been saved. You might have chosen a guy on the top, on the upside. In that case, you would have saved these people. And similarly for saving people on the left also, that if you chose this guy, then you would have saved these people. If you are able to visualize this much, it's enough. Now you just need to find out the maximum area of all these, the maximum number of cells among all these, and that's your answer. Is it clear or not? Please write clear if it is clear. Okay, great. What about others? What about others? Okay, great. So the code I wrote is just like this. For every test case, I took n and m as input, and after that, I stored the the minimum number of people who will get infected in a variable infect, and then said n into m minus infect. And now these four things are just simple mathematics: n into y, m into x, and basically you can just calculate. I calculated this area, this area, this area, this area, the number of people who will get infected, and stored the minimum. The reason I calculated the minimum was because I felt calculating this area easier than calculating the green area directly. And I used long here because N and M could have been pretty large, so there was some risk of getting overflows. And I was a bit lazy in writing one L everywhere, so I just took them in long directly. Okay, let's move on to the next problem. This problem is quite good. This one is good. Till now, the problems were very simple, but now this problem will be at some and somewhat decent level. In the problem, we have been given a directed tree. We have been given a directed tree, and the edges are directed away from the root, which is actually telling us that root will not have any edges coming towards it. This was DP on trees. Yeah, somewhat DP on trees. Yeah, DP on trees. And we have been told that for each I equal to 1, 2, 3, 4, and till n, count the number of vertices which can possibly appear at the ith position of the topological order of the tree. So as a prerequisite, first of all, you must know the prerequisites for this problem. Is first of all trees. After that, you must know about topological sorting, like at least know what it is, even if you don't know how to find it, but at least you should know about it. And uh, yeah, that's it. That's what you need to do. So we have to tell that whatever be the topological sorting, like for all the possible topological sortings at, let's say, I equal to 2, what are the possible nodes? What is the count of the nodes which can be coming at the second position in the topological sorting? For the first position, would anyone like to guess what can be the what are the what is the possible number of count? Sorry, what is the count of possible number of nodes which can come at the first position in the topological sorting of this tree? Yeah, the nodes having in degree equal to 0, and there will be only one node having the in degree 0, which is root. So we will have one for sure for the first case. For the second case, how many nodes will be there? Like, what will be the nodes? Any guesses on what would be the nodes? These would be the nodes which are directly connected to the root. Only those nodes can come at the second position, right? Can I say that if I talk about any node, let's say I'm talking about a node, it the it cannot really come at any position in the topological sorting. Like it is not possible that you can take it at any position. There are some particular positions where it can come in a range. If it is at a distance of 2 from the root, like if you consider root as the first node and it is coming at the second level, let's say if this is the first level and it is coming at the second level, then it cannot come in the topological sorting before the position 2. Does this make sense? If the level of a node is equal to 2, then in the topological sorting it cannot come at the first place or any place before 2. Right now we are just trying to see if it is possible to find contribution of each node. This is what we are trying to do right now. So if the level is 2, in that case we know that the node cannot contribute for these places, but it can contribute for other places. It might be the intention that, hey, if there is from the first position to the second, let's say if there is the root is 1 and a node is coming here, then for the second node which is coming at the level 2, I can have it at the second position, I can have it as at the third position, at the fourth position, and like and so on till n. Does this come to your mind? Does this kind of thing come to your mind? Yes or no? Okay. What I can do is that in the tree, I just wanted to find for every node at what places can it come in the topological sorting. I realized that, hey, if level is 2 for this node, this like I cannot have it before 2 in the topological sorting. But can I have it at the third position? Can I have it at the third position right now? Please tell me. Can I have this node 2 at the third position in my topological sorting? Yes or no? Yes, I can have it. Because what I can do is that I have this 2 and 3. What I can do is after like instead of going to this 2, I can include this 3 first. Okay, sorry. Yeah, I can I can include 3 before 2, so that I would have this coming at the third position. Can I have it at the fourth position? Can I have this 2 at the fourth position? No, I can have it actually. I can take one. like I can have a topological sorting like 1, 3, 4, 2. In that case, 2 can come at the fourth position as well, right? Four, like 2 can come at the first position. Sorry, 2 can not come at the first position because 1 would definitely come before 2. Like all the parents of 2 should be coming before 2. Only then 2 can come. So whatever the level of 2 was, it cannot come before that. So we realize that hey, 2 can come at the second position. It can come at the third position if I take up some other node on some other branch. If I take 3 after 1, in that case, I can have 2 at the next place. So having the node 2 at third position is also possible. Having node at fourth position is also possible because I can take uh, 1, 3, 4, something like that. I can also take 1, 3, 4, 5, something like that to have 2 coming at the fifth position as well, right? So the intuition which we got here was that I cannot have it before level node, but after that I can have it till end, right? This is actually wrong. This intuition is actually wrong. But like the idea is pretty much good till in this case. Huh? In this case, it was good idea. But if there was some child as well, if this node had a child as well, in that case, you will see key you cannot have 2 at the sixth position as 6 will be able to come only after 2. Yeah, 2 has to come before all the children of its node. So for any node, for any node, the number of ancestors it has, or basically its level minus 1. Level of node minus 1 is the number of nodes coming before it. Um, like we saw that it cannot come at level minus 1, level node minus 1. For these many positions, the node cannot have any contribution. And for the size of node, where the size node is telling me about the number of nodes in the subtree of 2, minus 1. For these nodes, for this number of nodes, 2 cannot come at the end either. If there was some more child of 7, like 6 as well, let's say if there were 3 people in the subtree of 2, then 2 cannot really come at the last 2 positions. 2 cannot come at the last size node minus 1 number of positions. So 2 will have contribution only in this area from level of node to n minus size node plus 1 in this area. For all these indices, I have to increment the count by 1 that, hey, I know a node which can come to these positions. And I just now need to consider for all the n nodes, for all the n nodes, and for all of them, I can just find these ranges and add it to my answer. Add it to the actually add it to a, to a vector, and at the end, whatever value I have in that vector would be my answer. So does this make sense? We have one part left, that how would we uh, increment everything here, but except that, is everything clear? The idea behind this approach? Okay, great. Now for the part of having range updates. We are just having some range updates in which we are having some starting range, some ending range, and we want to increment x in that range. X is some integer, है ना? Or not even some x, but we just want to increment it by 1. Right. This is the kind of updates we want to make. There are many ways of doing this. Maybe like array difference, or also known as partial sum or sweep line. If someone doesn't know about array difference, then you can look at that TLE channel. Priyansh made a video on this channel itself for the technique array difference. Or you can use something like lazy propagation if you don't know about anything, but you have a template of lazy propagation. You can do this, or maybe you can use some sets or maps, which is like just array difference using set. So you can use this kind of techniques for having these range updates. And after all that, you will have your answer vector. Okay, so let's see the code. What I did for every test case is, yeah, one more thing. How will you find the level of every node? How will you find the level of every node and the size of every node, the subtrees of every node? You can just use DP on trees and basically run DFS and store these things. So if you're coming till this problem, you should already be good at this part. You should already know how to find this part. So what we are doing here is just first of all find the root. Since we are not directly given the root, what we can do is uh, find the node which doesn't have any degree. For that, you can even have just an array, but here I used a set. Um, it's fine. You can have anyway for finding the root, and from the root you can run up a DFS function, which will find out the size of the subtree and the level of the node. And after that, we can remove these lines. After that, we can have something like an answer vector, in which here I have used array difference technique, where I'm incrementing the starting range and decrementing the ending range plus one guy. And this debug is also not required. After that, taking the prefix sum of this array to get the answer and then printing it. So that's how we can do this problem. So is it clear? Should we move on? Okay, you have already written that it's clear. Okay, great. Let's see the next problem then. This is the problem reach anywhere. This is also a good problem. In the problem, we have been given a simple undirected graph. The prerequisites here would be to know about graph first. And we have to find the smallest non-negative integer k. Smallest non-negative integer k. Have not you reached the problem? I didn't understand, Sudhanshu. What did you want to say?
I was saying that I wasn't able to reach this problem in the contest.
Oh, okay. In that case, I would suggest you to try it yourself first. Looking
Yeah,
at the
yeah,
solution
sure.
directly will just spoil it. Yeah. You can watch the recording of PCT after this
Yeah, sure.
once you
Like
have tried.
I'm going to leave, but yeah, you can discuss the problem with the other person.
For now, I'm explaining it.
Okay, okay.
We have to find the smallest non-negative integer k such that for every vertex u between the range 1 to n, there exists a walk of length exactly k from 1 to u. Leave this wala nahi hua. No problem. You can solve the problems after, since the contest is over. Make sure to solve the problems. So here we just have to find the smallest index k such that for every vertex, it is possible to go from the vertex 1 to that index, that vertex u, in exactly k moves using a walk. It's not a path. So what walk means, what walk means is it is like path where we can visit edges or um, vertices multiple times. There is no foundation that we have to visit every node or edge only once in a walk. Okay, and we have to find the smallest possible value k such that we can go to every node from 1 to every node in exactly k moves. For every node u, we want to go from 1 to u in exactly k moves. And in case if there is no possible k, if there is no k possible for that, in that case we have to return -1. So the initial intuition for this is that if I'm starting from a root and I want to go to the node 2, um, let's say you can reach, maybe you are having a graph. I'm not drawing a big graph now, but just some normal thing. Maybe you have a graph, and for the fifth node or for the third node, you can reach there in 2 moves. Like if you can reach there in 2 moves, and k is anything, k is any even number greater than equal to 2. So would you be able to end up at the node 2 after exactly k moves? Say yes or no in the chat. What do you think? Would you be able to end up at the node k, at this node 3 in exactly k moves on a walk if that k is greater than equal to the number of moves it takes you to reach there? If k is of the same parity, then what you can do is reach there in 2 moves. You reach there in 2 moves, and after that you can just go ahead and come back, go ahead and come back. Just keep going to and fro with the neighbor. So in that way, you can waste up all the remaining moves and end up at that node in exactly k moves. But if k was odd here, or basically of having a different parity, in that case, you would not be able to stay at that place in exactly k moves. So what we want is that we want to reach to every node in either odd number of moves or even number of moves. Right, right. I just want to find out the cost of reaching to every node in even number of moves and in odd number of moves. Then I can say that whatever be the maximum distance, let's say from 1 to any node u, whatever is the maximum distance of reaching to that node with the even distance, I would require k to be at least as large as that. And making it larger than that is not important for me, is not doing any good for me. So I would just say that k will be equal to the maximum value of the distances of every node where distance is even, where I'm going to every node in even distance. Right. If I can do this, obviously doing this is not very easy, but not very intuitive for anybody in the first uh, run. But if I can reach to, if I can just find out a distance array u, if I can find something like dist even array, which will tell me, I would just give it a node u and it will tell me the distance. It would, this minimum distance I need to travel to go from 1 to u in even moves. Now I can just check that whatever be the maximum value in this array for all the nodes, I require k to be at least as large as that. Otherwise, I won't be able to reach to the node with the maximum distance. And I don't want to have k large. I want to have the minimum value of k. So the minimum value of k, which is greater than equal to this, would be just equal to this, whatever be the value of this guy. Similarly, I can do the same thing for distance even. I can just find out the distance for every node. Sorry, dist odd, where the distance is odd. I can do this. Just 1 minute. Yeah. So here the thing is exactly same. Now the stuff is again exactly same. Just find out the maximum of all this, maximum of this, and whatever be the minimum of both of these, whatever be the minimum of both of these, just have this as an answer. But there is one more thing which you need to remember, while finding it, that if there is any node where you cannot reach in odd steps, or there is any node which you cannot reach in even steps, in that case, don't consider it. And I think that if you are up solving this problem, in that case, this much hint should be enough for you. And let me tell you about my implementation for this. I just assume that, let's say, instead of n nodes, I have 2 into n nodes. And the nodes u and v, which were being connected, like the u and v, we were being given connected in the problem. Instead of that, initially I was being given the nodes 1 to n, but uh, I'm not having the nodes 1 to m now. Now I'm having nodes from 1 to 2n. And instead of connecting u and v, I would connect u to n plus v to n plus u, n plus u to v, and n plus v to u. In this way, where uh, u is telling me we use the node where I want to end up in even number of steps. Since I'm starting from here, I would have it in even number of steps, and n plus u will, like all the nodes in the range from n to n plus 1 to 2n, all these nodes would be reached only when I would have moved odd number of times. Because I started from the node 1, and I would be going in first step, I would be going from a node in the range from 1 to n to a node in the range coming in the range from n plus 1 to 2n. Since edges are being connected only between nodes in these ranges and not connected between them. So this distance even would be nothing but distance of one, like distance 1 to n. In the distance array I can create for all these 2n nodes. For the first n nodes, it is telling me about the distance of nodes from 1 to n in even number of moves, and distance odd is gonna be here distance of n plus 1 to 2n. Now I have not really explained up everything and how and why I'm doing this. This is just about my implementation, and I've given hints earlier. So please don't get confused that how did I directly write up this from this or this from this. After that, once you find out the distances, you just need to find out the maximum value here and here. And first of all, check that if there is any node which is not visited yet in this range, if there is any value which is not visited yet, in that case, just leave this part. If there is any value which is not any node which is not visited here, then just leave it. Otherwise, consider this, and whatever be the maximum distance here, just compare it with answer and store the value which you want to store in answer, and it would be just print it. So the way I did implement it is like this. I took n and m as input. Then I went for, okay, here I'm having zero based indexing. Nodes are from 0 to 2n minus 1 here. I connected u with n plus v, n plus v with u, v with n plus u, and n plus u with v, and created a distance array of size 2 into n. Initialized it everything with -1, which means that not visited yet, and have a queue here. I'm applying a BFS. Distance u and q dot, like for the starting node, I'm having its distance 0 and pushing it into q. And then there is just simple BFS direct, like simple BFS, nothing special. After that, I said that let's initialize our answer by -1. Check if there is any node having a distance equal to -1. If the count is 0, which means that there is no such node, it means that all the nodes are visited. So just find out the maximum value here. And in case if answer was -1 right now, or answer is greater than the minimum distance, then update answer, otherwise it's fine. And do the same thing for the odd number of moves as well. And after that, you can just print the answer. So that's how the problem is. I hope it's clear. And for the ones who have been watching this on YouTube, if you watched till here, please consider liking the video and subscribing to the channel. And thank you.